Today's lesson is 9-4 day 1. We're going to graph quadratic equations and recognize the effects of changing the constant and or coefficients. Number 1, you're not going to write any of this down. In fact, you're not going to write anything down until I tell you to do so. There's just a couple of things we want to look at before you actually start taking notes. The first one is actually just going to be a review of 9-3 of graphing quadratic functions. So again, you don't have to write this down, just need you paying attention. We're going to subtract the x squared from both sides to get the y by itself, so that way it's an ax squared plus bx plus c form. We're going to name the a, b, and c's. A is the number in front of x squared, b is the number in front of x, and c is the number on the end. So we have -1, 6, and -5. Then we're going to find the axis of symmetry given the formula, -1 times b over 2 times a. We're going to plug in the b and the a. Multiply the top and the bottom, we get -6 over -2, which is 3. We're going to make a table of values where that 3 is going to be our middle term right here. We're going to fill in the rest of our table. We need 2 less than 3, so 1 and 2, and 2 more, so 4 and 5. We're going to plug each one of these in, and we get 0, 3, 4, 3, and 0. So we completed a table with 5 ordered pairs. Then we're going to plot the points. Notice that it makes a U shape. Again, if you're graphing and it's not making a U shape in this chapter, you've done something wrong. Notice our A was negative, so our parabola opened downward, and it should have. So we drew our parabola. We're going to draw the axis of symmetry. That's the line that cuts it in half. Remembering that you have to have your x equals when it comes to the axis of symmetry, so x equals 3. Label the vertex. The vertex, again, is the maximum or minimum point. So our vertex is 3, 4. It's also that third value in your table, and it's a maximum because it goes up, 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 and hits the maximum point before it goes back down. We're going to name the zeros. Again, the zeros are where it crosses the x-axis right here. So it's going to cross at 1, and it's going to cross at 5. So my zeros are 1 and 5. Those need to be in braces or brackets. And finally, number 10 is to state the domain and range. Domain, again, is always all real numbers with parabolas. The range is everything from this top maximum point and down. So it's y such that y is less than or equal to, because it's opening downward, and it's less than or equal to this top point, which is 4. So it's y such that y is less than or equal to 4. Again, that was just a quick little review. You did not have to write any of that down of what we did in 9-3. It says, in a quadratic function, f of x equals ax squared plus bx plus c, if the b value is 0, then the axis of symmetry will always be x equals 0, meaning that's going to cut it in half at 0. In the next graphing problems, we'll use the domain -2, -1, 0, 1, and 2, because our b is always going to be 0. In other words, we're not going to have a bx here. We're just going to be looking at the ax squared, or the ax squared and the c. Right, again, you still aren't writing anything down. You're just paying attention here. We're going to look at f of x, which is x squared, and g of x, which is 1/2 x squared. And we want to know what you think. Do you think it's going to be wider or more narrow? The difference here is that one of them has the 1/2 in front of the x squared. So we're thinking, what is that 1/2 going to do to our graph? So we're going to look and see by making tables. Notice, just like whenever I did my other tables, everywhere I saw an x, I plugged in a -2. -2 squared was 4. Plugged in a -1. -1 squared was 1. 0 squared was 0. And so on. Again, here, I put in -2. -2 squared is 4. Half of 4 is 2. And so on. So then I'm going to graph each one of these. There's my f of x equals x squared. That's my actual parent function, because nothing gets more simple than that. Then here is my blue, or my blue graph, is my g of x, which is 1/2 x squared. So all we're really wanting you to do is notice what happens when we put the 1/2 in front of the x squared. And as you can see, it actually makes it wider. So when we say compare, this is what we're going to write down. So this is where I need you to start writing. I need you to write the f of x and the g of x, and then I'll need you to write the compare statement. You're not drawing the tables, you're not drawing the graphs. you're going to say that g of x equals 1/2 x squared is wider than f of x. And it says when the absolute value of a is less than 1, the graph will be wider than the parent. In other words, if there's a decimal or a fraction or any number between 0 and 1, okay, decimal or fraction here, then it's actually going to be wider. All right, number 3, again, we're going to do the same thing. We're going to compare f of x as being x squared to g of x being negative 2x squared. We want to know if you think A, g of x will be wider, or B, g of x will be more narrow. We looked at the 1/2. The 1/2 made it wider. What do we think putting a negative 2 in front of the x squared is going to do to it? And again, I'm going to make tables and actually draw the two parabolas. You do not have to do that part. So you are not drawing the tables. There's my table for f of x equals x squared. And there's my graph for that one. Again, that's just my parent function. Now we're going to look at what happens when we put a negative 2 in front of the x squared. And here's my graph for that one. So again, we're going to look and say, okay, what did it do? Well, first of all, the negative flipped it upside down. So instead of opening up, it opens down. The 2 actually made it more narrow, because if I were to flip this back up, the blue line is going to be more narrow than the red line. So here's what you're going to do. You're going to write down number 3, f of x equals x squared, g of x equals negative 2x squared, and you're going to write the compare. You're going to write this part right here. G of x equals negative 2x squared is narrower and opens down. So the fact that there's a 2 in front makes it more narrow, meaning that it's a whole number. Again, fractions make it wider, whole numbers make it more narrow, and the negative in front made it open downward instead of upward. So again, you're going to write down this part, and this part down here. You are not writing the tables or graphing. Please make sure you have that written before you move on. All right, number 4. Again, we're going to look at these. F of x equals x squared. Again, it's just our parent. G of x is x squared minus 5. So this time we're going to look and see what adding or subtracting something to the end of the x squared is going to do to our graph. It says what transformation will occur from f of x to g of x? A wider, B narrower, C shifts up, D shifts down. So we're actually going to look at that, and again, this time you're not going to write the tables, and you're not going to show the graph. You're just going to write the compare when we're finished. Okay, so this is what the red quadratic looks like whenever I graph it. My g of x is x squared minus 5. It's this blue U shape down here. So we're going to compare the red line to the blue line. And basically, it's not wider or more narrow. It's just shifted, and it's shifted down. If I start at the red line and I go to the blue line, I'm shifting it down 1, 2, 3, 4, 5 units. So I've shifted it down 5 units. So for number 4, you're going to write f of x equals x squared, g of x equals x squared minus 5. And you're going to write our compare statement down here at the bottom. The graph of g of x is translated down 5 units from f of x. So again, you're going to write down your f of x or g of x, and you're going to write down the compare. You are not writing the tables or the graph. Please make sure you have that written before you move on. All right, quadratic functions, it says compare f of x to g of x, which is what we're doing. I want you to write down what's in this box, so pause the video if you need to. Transformations. If I'm looking at a, which is the number for the x squared, if the absolute value of that is less than 1, it's wider, meaning that it's a fraction or a decimal between 0 and 1. And if the absolute value of a is greater than 1, meaning it's a whole number, 2, 3, 4, 5, it is more narrow. So again, you're writing down what's in the box. So you're going to shift up is when your C is plus, shift down is when it's minus. It opens up if A is positive, or it opens down if A is negative. If you need to pause the video, feel free to do that. Alright, so we're going to look at number 5 and number 6. Number 5 and number 6 are both graphs, and I want you to pick whether you think number 5 is A, B, or C. And then I want you to look at number 6 and pick whether you think it's A, B, or C. Please take a minute to do that. If you need to pause the video, go ahead and pause the video. Alright, let's see if you got it correct. Number 5 should have been C. The reason that it should have been C is it's much wider, okay, and that has the 1/3 in front, which is the fraction. It's not shifted up or down, so it shouldn't have the minus at the end. It's also opening upward, so it shouldn't be negative in front. Alright, so for number 6, you should have gotten A, because it's shifted down 3 units, 1, 2, and 3. It's not opening downward, so it would not be B, and it's not wider, so it should not be C. Please make sure you also write what's in the purple and what's in the red here. A is positive, opens up, vertex at -3, and over here A is positive, opens up, and absolute value of A is less than 1, so it's wider. Alright, same thing with 7 and 8. I want you to go ahead and pause the video and try 7 and 8. Pick out whether or not you think number 7 is A, B, or C. And then look at the graph of number 8 and pick out whether you think that one is A, B, or C. Alright, hopefully you've had a minute to try this on your own. Number 7 should have been B. The reason being, it's opening downward, so the number in front of the x squared should be negative, and B is the only one that's negative. Also, it's shifted up 3 units because of the +3 on the end. Number 8 should have been C, because it is still shifted up 3 units, but it's opening upward. So the x squared is positive, and it has +3. With A, the 3 in the front of the x squared would have made it narrower, and neither one of these is narrower. Please make sure that you have number 7, B, and then A is negative, opens down, vertex at +3. Make sure you have number 8, C, A is positive, opens up, vertex at +3. You do not have to copy down the graphs. Alright, we're going to look at 9, 10, and 11, and our instructions are to compare each graph of each function with the graph of f of x equals x squared. So, in other words, we're comparing them all to the parent. So if we're looking at g of x, first thing I notice is that there's a negative in front of x squared, so that's going to make our graph open downward instead of upward. And I notice the +5 on the end. The +5 is going to shift it up 5 units. So that's what we're going to write for that one. So for number 9, I want you to write g of x equals -x squared +5. And I also want you to write everything in the blue. You're going to write the parabola would open up instead, or would open down instead of up, and it will be shifted up 5 units from the origin. Alright, go ahead and take a minute and pause the video and try to do the same thing with 10 and 11. Alright, hopefully you've had a minute to try it. For number 10, first thing I notice is that there's a 2 in front of the x squared, and since that's a whole number, I know that that's going to make it narrower. And then I notice the -2 on the end, and the -2 is going to shift it down 2 units. So we're going to write the parabola will be narrower, and it will be shifted down 2 units from the origin. If you got that right, good job. If not, please go back and fix it. Or if you said narrower but maybe didn't put shift down 2 units, please add to what you have. Number 11, if we look at the number in front of the x squared, it's 1/2. Since it's a fraction or a decimal that's between 0 and 1, it's going to make it wider. So you're going to put the parabola will be wider. And it will be shifted up 1 unit from the origin because the +1 on the end is going to shift it up 1 unit from the origin. Again, if you need to change or add or subtract anything to what you wrote, please feel free to do that at this time. All right, number 12 says compare each function to the parent, f of x equals x squared. If the graph g of x is x squared plus 5 is translated down 10 units, what will the equation of the graph be? So right now, if I'm comparing g of x to x squared, I know it's shifted up 5 units from the origin. If I translate that down 10 units from the origin, it's going to be at a -5 instead of a +5. So it's going to go up here from +5 and it's going to shift down 2 units and be at a -5. So your equation would be, you could pick h of x equals, or you can pick y equals x squared minus 5. Now we're going to look at 13. Go ahead and try 13 on your own. It says if the graph of g of x equals 2x squared minus 2 is translated up 8 units, what will the equation of the graph be? So here, if I look at it, it's translated down to the -2 because of the -2 on the end, and I know that it's more narrow because of the 2 in front. But if it's translated up 8 units, if it's down here at -2 on the y-axis, and I shift it up 8, it's going to be at a +6. So my new function is still going to be more narrow. It's still going to have the 2 in front, so 2x squared. But instead of -2, it's going to be up at a +6 if it's translated up 8 units. Please make sure that you have all the writing and the answer. So the question for number 12 and the answer for number 12 written. Please make sure that you have the question for 13 and the answer for 13 written down for this one. If you need to pause the video to do that, go ahead. So we now should be able to graph quadratic equations and recognize the effects of changing the constant and or coefficients. Right, you do not have to do that before you go, but I want you to go ahead and have out a clean sheet of paper and go ahead and write down your assignment, the homework in the yellow at the top. It's lesson 9-4, page 637, 5 through 8, 14 through 17, 24 through 25, 29 through 32, and 39 through 40. It says you don't have to graph any of the problems on the homework. You're just answering the questions like we did on the video. So once you have gotten your homework part written down on a clean sheet of paper, this is the end of your video. Thank you for watching.